Next, I would like to invite Mohanson to the stage. He will talk about Spawn, a new cross-script calling method. Please welcome Mohanson. Would you like Mike? Is that one? Yeah. Okay, maybe not. Maybe this.
Hello. Hey everyone. Today I'd like to introduce some exciting new features in CKB script development. One of these features is Spawn, which was added as part of the CKB Meeple hard fork. The Meeple hard fork introduced several interesting changes, and Spawn is one of the key additions. In CKB script, Spawn refers to a concept and a set of syscalls used for creating new processes. Unlike the execute syscall, which is introduced during the Mirana hard fork, Spawn provides a more direct way to enable cross-script calls, making the process simpler while offering greater control and optimization. In 2021, during the Mirana hard fork, we introduced the execute syscall in the CKB VM. Execute syscall allows loading and executing a new script within the current execution space. While this feature is powerful, it can sometimes be inefficient, particularly when the current execution space needs to be preserved. Specifically, when using execute or state information about the current script is discarded. We hope to find a way to preserve the context of script. Yes, this is what Spawn is supposed to do. The Spawn family of syscalls in the CKB VM is inspired by the Linux standard, providing developers with an efficient way to create processes. As a result, it uses familiar terminology like process, pipe, and file descriptor. To avoid any confusion between processes in the CKB VM and those in an operating system, let me clarify what processes in the CKB VM refer to. In the CKB VM, every running script is considered a process. A process is essentially an entity with its own independent execution space. At the operating system level, CKB VM is still a single process and a single thread program. In the CKB VM, Spawn is primarily implemented through the Spawn and Spawn cell functions. These two functions offer nearly the same functionality, with the key difference being that Spawn cell locates the cell using the code hash and hash type, while Spawn requires the developer to provide an absolute index and source. These function signatures are as follows. At a low level, Spawn cell is simply a wrapper around the Spawn. Of note is the Spawn args parameter, which allows you to pass or get some information, such as the process ID of the child process. Like Linux, CKB VM uses pipes and file descriptors to pass data between processes. The pipe syscall creates a pipe, a unidirectional data channel that can be used for inter-process communication. The tuple of returns is used to return to file descriptors, referring to the ends of the pipe. The first element refers to the read end of the pipe. And the second element refers to the right end of the pipe. Data written to the right end of the pipe is buffered by CKB VM until it's read from the read buffer, returning the actual number of bytes read. The counterpart to the read function is write. This syscall writes data to a pipe through a file descriptor. It writes up to the number of bytes specified by length from the buffer, returning the actual number of bytes written. The close syscall manually closes a file descriptor. After calling it, any attempts to read from or write to the file descriptor at the other end will fail. The child script uses inherited FDS syscall to verify its available file descriptors. A file descriptor must and can only belong to one process. The file descriptor can be passed when using the spawn function, as I demonstrated when introducing the spawn syscall. The last function is wait. The syscall pause execution until the process specified by PID has completed. Then let's talk about error handling. There are 5 unique errors that can be returned from the spawn family of syscalls. Most of these errors are quite self-explanatory and can occur when you pass incorrect arguments or attempt to double-close a file descriptor. Among these, a notable error is other end closed. This error allows us to implement a function like read all to read all the data from the pipe at once. Many programming languages provide similar functions in their standard libraries, and you can easily implement this functionality yourself in the CKB VM. Since Spawn operates within its own memory space, independent of the parent process, it can mitigate certain security risks, particularly in scenarios involving sensitive data. While some other blockchain virtual machines, such as the EVM, also offer cross-contract call functions, but these calls tend to be quite expensive, especially when invoking child contracts repeatedly. This is primarily because it requires continuously creating and destroying a virtual machine to complete each call. Since the CKB VM provides a pipe implementation, this means that no matter how many times you call a child script, you only need to create and destroy the child script's execution space once. The Spawn family of functions in the CKB VM offers an efficient, flexible, and secure method for process creation, particularly in scenarios involving some very complex scripts. Using Spawn can enhance system performance and security. By understanding and mastering the use of Spawn, developers can more effectively manage scripts while building dApps. Thank you.